Good morning, everyone. Let's try that again. Good morning, everyone. Good morning. Perfect.
Hey everyone, Donovan Brown here with a video on Microsoft Fakes. We're going to discuss what fakes are, how we add them to our test projects, clearing those pesky warnings, and actually writing a test. A true unit test has no external dependencies, which means we must test our code in isolation. That is the entire purpose of mocking or isolation frameworks like Microsoft Fakes. We want to fake out any external dependency so only our code is being exercised. Microsoft Fakes come in two types, stubs and shims. Stubs are lightweight generated implementations of interfaces that allow you to define the behavior using delegates. Shims are a way to detour methods of concrete classes to delegates you define in your test. Shims can even be used with third-party assemblies. Let's begin by first taking a quick look at what we're going to be testing. It is a very simple class that opens a file from the hard drive. The goal of this class is to simply load each line of the file into an array. However, if the file does not exist, the test will fail. Not because the code is broken, but simply because the file does not exist. So I want to isolate my code from the external dependency of the file system. You can replace the file system with any dependency, for example, a SQL Server database or a web service. The concept is the same. But with Microsoft Fakes, you can still test your code. To test the code, we must first add a test project to our solution. With the project added, we now need to add a reference to the project we want to test. You instruct Microsoft Fakes to generate your stubs and shims by right-clicking on a reference and selecting Add Fakes Assembly. Because we want to fake the system.io.file class, we are going to right-click on the system reference. Visual Studio will add two new files to your project under the Fakes folder and new references to the generated fakes. The first thing I do after adding a Fakes assembly is build my project so that I can correct any warnings. By default, Microsoft Fakes attempts to produce stubs and shims for every type in the selected reference. However, it is not always possible to generate stubs and shims for all types, and when it fails, it will generate warnings. We are going to modify the files added to our project so we only fake the actual classes we intend to use. This will remove the warnings and speed up our compile time. The first change to the files we are going to make is to set the logging mode to diagnostic. This will give us further insight on what types are causing the warnings. After modifying the files, rebuild the project. You will now see lots of warnings. Now let's modify the files and instruct Fakes not to stub or shim anything. Build the project again and notice all the warnings are gone. Now let's have Microsoft Fakes just generate shims for the system.io.file class. Build the project once more to see if any warnings remain. As you can see, we have drastically reduced the number of warnings, but there are still some types used by the file class that Microsoft Fakes cannot generate shims for. We can modify the Fakes file to have Microsoft Fakes ignore these types. Let's remove the first warning by hand and then copy and paste that solution for the remaining warnings. To select a column of text, make sure you hold down the Alt key before you start your selection. Now we're going to paste the text into our Fakes file and create remove elements for the rest of the types causing warnings. I am now going to use a regular expression with the find and replace dialog to complete the remove elements. Let's build the solution one final time to confirm all the warnings are gone. With all the warnings taken care of, we can now move on to writing our test. When using shims, you are required to create a shims context. This is a safeguard so your shims don't affect the IDE. You do not need a shims context if you are only using stubs in your test. All of our stubs and shims will be inside a fakes namespace alongside the types being faked. You can assign a delegate to every method in the faked type, including the get and set methods of the properties. The naming convention used for the faked method is the original method name followed by the type of each argument in the method signature. We can perform any action we need in this delegate, even throwing in an exception to simulate an error condition, for example, file not found. For read all lines, we simply need to return an array of strings. Now call the constructor of our target type, passing in any text value you want. The value here is not important because the file system will never actually try and open the file. Our delegate will get called instead. Finally, add an assert to verify our target class loaded all 3 lines. That is it. You can now execute this test and Microsoft Fakes will detour the call to the file system into your delegate defined in your test. To prove that the file system is not getting called, let's set a breakpoint and debug our test. As you can see, when our code executed read all lines, it was actually calling our delegate in our test. I hope you found this intro into Microsoft Fakes helpful. Until next time, I'm Donovan Brown.